So I take you now into the world of geosciences and into a focus on using digital data, particularly Earth observations, for decision support in land use, management, and for climate. And I'll start with this really important graphic that just reminds us that our economy is entirely embedded within nature. I think this realization is slowly making its way into business and into government, that we are entirely embedded in biodiversity, and no business can ignore that fact. The pressures of our economy on the environment, which we perceive as climate change, ultimately feed back onto the economy. So we have to find a way forward that is going to lead to the definition of sustainability, which is an economy that is not destroying the fundamental basis in which it operates. So that's the motivation behind the science that I do and my engagement with business in trying to use the knowledge we've gained about natural systems. And if we take the example of land management, it's traditionally been about maximizing yield. So that might be timber production or crop production or the generation of livestock outputs and dairy. But we now realize that land obviously has other values. It provides regulating services around climate and pest control. It supports biodiversity, which has an intrinsic value of itself. And land also generates supporting services which we've not valued previously. For instance, soil formation or the provision of regular and clean water supplies. These have all been uncosted in our economy. So if we only optimize for provisioning services, we tend to lose out on all those other important factors, and ultimately that degrades the ability of our economy to function. So how can we generate decision support systems that help us weigh up all these separate valuations and provide an optimal system across a whole range of scales, from business to society, and that support global treaties? So the approach that we're taking advantage of is the unprecedented growth in Earth observation data over the past couple of decades, and particularly in the last 5 years or so, when the launch of operational Sentinel satellites by the European Space Agency has allowed us to observe the Earth's surface at unprecedented spatial detail and temporal updates. So we're now able to see the states of our forests and our fields, as we see here, at unprecedented resolution, along with ancillary data such as weather data and soils information, land cover mapping systems. We can begin to combine this information with our models of how the underlying ecosystems operate, and thereby generate data underpinned and scientifically robust decision support systems. So for instance, in my group, we've been focusing on using relatively simple models that represent the fundamental processes, in this case of carbon cycling in the diagram to the top left, the flows of carbon through different live and dead organic matter pools and their return to the atmosphere, calibrating that model based on satellite observational time series at 20-meter resolution across fields across the UK. And those satellite data there show you through winter, a winter wheat crop stabilizing its leaf area, and then that exponential increase as spring comes. The satellites provide us with the local relevant data on the strength of growth in that field, and that allows us to calibrate critical parameters within the model that are specific to that localization, and that reflects the soils, the management decision, the fertilizer additions, and so on. And we can take advantage of the computational capacity within Edinburgh, so the Archer 2 supercomputing system, and also our colleagues in the Edinburgh International Data Facility and the Data Slipstream project that can provide us with the data in near real time. So we're generating that frequent, highly localized update of the system of interest so we can provide this decision support. So here are some schematics of some fields growing winter wheat in Scotland. On the left-hand side, a couple of fields with their yield generated by harvest, so that's recorded harvest weight collection of yield. And In the center panels, you can see our prediction of that yield 4 months earlier. And another graph, I think this is the last one, showing our predicted yield by our Dalek crop model and satellite data versus the observations 4 months later collected by the farmer in situ. So a capacity to drill right down into fields and find the hot spots of yield and also the low spots, and the capacity then to provide decision support to farmers around optimizing their yield and managing their nitrogen inputs more efficiently. And that's a critical part of generating a more circular economy that will create a sustainable agricultural environment. Another example about livestock density and activity from space data. How do we manage our livestock to optimize their productivity and also the stores of carbon in soil in pasture areas? The left-hand side, we've got a map of the livestock unit census data across the UK. So that's the physical record that every farmer submits on their livestock and their location across the UK. And that is our estimated livestock density generated from our interpretation of grazing on grass observed from space and interpreted through our model. So it's a completely independent data set, again with a strong correlation. The advantage being we can update every field that we observe weekly to say what the livestock intensity, what the grazing is, and what the impact on that patch of land, and how to optimize grazing distribution so that forage is used effectively and soil carbon stores can be optimized over time. So the capacity is there to drill right down into the operational level and deliver to the decision maker. And my final slide, just to note the case studies, the use cases rather, that we have here. We've been focusing very much with our industrial partners on land manager decision support, so how to use nutrients more effectively. We're working now into irrigation and water management. We also track carbon stores within fields, and that's becoming a commodity and of great interest to land managers. And we have 2 industrial partnerships, one with Mercury, which is a startup looking to support farmers in more efficient nutrient management, and also with Environment Systems, which is an established company working in the environment space and supporting them with pasture management and forage optimization. But we're also exploring working with investors to provide commodity forecasts. Our technology provides many months improved capability of yield forecasts to the competition, and there's value there around supply chain management and, of course, sustainability metrics. It's not just about yield, but how sustainable is the yield? What's the water cost? What's the carbon gain or loss associated with management? We can provide probabilistically constrained uncertainty estimates around all those various components of the supply chain. And then working with policy, there's major national efforts to bring us to net zero. Agriculture and the food system is perhaps a third of all our emissions are associated with that. So we need to provide the digital data and the spatially located data to support net zero and climate adaptation. So I'll thank you very much for your attention. Thank you.